All right, let's dive right into a big one. You've seen it 1,000 times in the movies, right? The hero is cornered, bullets are flying, and they make this epic leap into the water. And they're safe. It's a total action movie staple. But is there any truth to it? Today, we're going to find out.
So yeah, this is the core question. Can a body of water really act like a bulletproof vest? I mean, it seems kind of crazy on the surface, but the science behind what happens is absolutely fascinating. So let's separate the Hollywood fiction from the surprising reality. Okay, to really get this, we need to set up a little showdown. We're going to look at two very different types of bullets, because it turns out not all bullets are created equal, especially when water gets involved. In one corner, we have the rifle bullet. This thing is designed for one primary purpose: insane speed over long distances. And in the other corner, you've got your standard pistol bullet. It's slower, built more for stability up close. And that single difference, speed, is the key to this whole puzzle.
So let's talk numbers. A high-powered rifle bullet leaves the barrel doing about 2,000 miles per hour. I mean, that is just staggering, way faster than a fighter jet. All that velocity packs an unbelievable amount of kinetic energy into that tiny little object.
Now compare that to the pistol bullet. It's moving at around 400 miles per hour. Now don't get me wrong, that's still incredibly fast, but it's 5 times slower than the rifle bullet. And that huge gap in speed changes absolutely everything when they hit the water. All right, let's switch gears and talk about the water itself. You know, it seems so soft and forgiving, but when you hit it with enough force, it behaves in a way you would just never, ever expect. And the secret to its power lies in a really basic principle of physics. And that principle is called drag. You've felt it. Just stick your hand out the window of a moving car. That force pushing back on you, that's drag. Now, just imagine that same force, but in water, which is about 800 times denser than air. The resistance becomes absolutely massive. This quote just nails it perfectly. For something moving that fast, the water molecules literally cannot get out of the way in time. The water's density creates this incredibly hard surface, so it stops behaving like a liquid and starts acting like a solid wall. So, we've got our two bullets hurtling towards what is, for all intents and purposes, a liquid wall of concrete. What happens in that split second they make contact? Well, you're about to see. Their fates could not be more different. Let's follow that super fast rifle bullet first. The instant it hits the water at 2,000 miles per hour, the drag force is so extreme, so violent, that the bullet's own structure just fails instantly. That's right. It doesn't just slow down, it completely disintegrates. The bullet's greatest asset, its incredible speed, becomes its own undoing. The forces are so immense that it just shatters into a cloud of tiny, harmless fragments right at the surface. Okay, now let's look at the slower pistol bullet. At 400 miles per hour, the impact isn't violent enough to make it shatter. So it holds its shape and it actually punches through the water's surface. But that incredible drag is still there and it hits the brakes hard. And how hard are we talking? Well, that pistol bullet, even though it survived the initial hit, loses all of its deadly energy and comes to a dead stop in only about 2 feet. 2! From there, it just gently sinks to the bottom, completely harmless.
So what does this all mean for our action hero diving off the pier? Well, after looking at the physics, the conclusion is kind of mind-blowing. That classic movie myth, believe it or not, it's actually true. Let's just look at the results here side by side. The super-fast rifle bullet shatters on impact, gets basically 0 penetration. The slower pistol bullet stops dead in its tracks after about 2 feet. In both cases, the water completely neutralizes the threat. And this is the big takeaway. And it's so counterintuitive. We're trained to think that faster means more powerful, more penetrating. But when it comes to water, that logic is flipped on its head. The incredible speed is actually a weakness. The faster the bullet, the worse it does. So this brings us to the ultimate safety question. How deep would you really need to be? Well, based on the physics, if you can get yourself submerged just 10 feet underwater, you'd be totally safe from pretty much any common firearm. The water is all the protection you'd need. So let's wrap this all up. What did we learn? 1. Water is an unbelievably effective barrier because of its density. 2. A rifle bullet's crazy speed is its own worst enemy, causing it to shred itself to pieces. 3. A slower pistol bullet gets stopped cold in just a couple of feet. And maybe the coolest takeaway of all, that classic movie scene? It turns out to be one of the few action movie tropes that is, surprisingly, spot on. And that just leaves us with a final thing to think about.
We've seen this incredible power hidden in something as simple as water. It really makes you wonder, right? What other everyday materials all around us have these extraordinary properties that we just completely overlook every single day? Something to think about.